Hello everyone and welcome to this other amazing session in which we are going to see how to integrate Tensorboard callbacks with TensorFlow. In this session we are going to look at how to log in information from our training process or from our different experiments into Tensorboard, how to view model graphs, how to do hyperparameter tuning with Tensorboard, how to view distributions, histograms, time series, how to log image data like confusion matrices, ROC plots, and finally how to do profiling with Tensorboard. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. In one of our previous sessions, we saw the importance of working with callbacks as they permit us to modify certain key information during the training process and also store certain information and do certain modifications during the training. That said, we have this Tensorboard callback right here, which we spoke of last time but didn't really get into. And so in this session, we are going to go in depth and see how to make use of Tensorboard to visualize on a web interface vital training information. You will notice also that this Tensorboard callback is going to be used in a similar way to the way we had done with the previous callbacks. So here we define the callback, and then just here you see in this callbacks argument we pass in the Tensorboard callback right here. So let's go ahead and copy this out. We have this, we could just copy from here. We've copied this to clipboard, and then now we go ahead and see how to pass this in our training process so we see exactly how it works. So here we open up this callbacks. You see the different callbacks we have created previously, and then now we're going to include our Tensorboard callback. So just here, let's add this text and add the code cell. We paste this out. Then let's take all this off and simply go. Let's run this cell. Looks fine. And now let's move on to our training process. Here we're going to have the callback. So we have the callback equal Tensorboard callback, and then we're ready to train our model. So let's check on this. We have gotten an error, unexpected keyword argument callback. Oh, okay, yeah, you should have callbacks. So run that again. Now while our model is training, you'll notice that there is this logs folder which has been created, and the reason why the logs folder has been created was because we actually specified that in this Tensorboard callback call. So here we have this log directory argument, and we're going to store in some information or some training information, and it's this training information that Tensorboard will use to display very important training information on a web interface. Now you could click open here and you'll see that you have these two folders. In this train folder, you see you have this information concerning the training data which has been stored here, and information for the validation which has been stored right here. The next thing we'll do is copy out this command, and then run it just below. So let's get to where we have visualizations, like reduce this one, and we have the visualizations here. Now we're gonna have this. We're gonna see how we're gonna replace these visualizations with our Tensorboard visualizations. So we paste this out. We have Tensorboard log dir path2 logs. Then we created this log dir variable here which takes in our path. So let's get back, and then instead of putting our path directly, we just have actually this log dir. So we have the log dir. Now before running this, we are going to add this code cell and then load this Tensorboard notebook extension. So here we have load extension Tensorboard. We run this, and then you see already loaded. We have loaded this already. Anyway, we have that, and then Tensorboard now. So we run this, and then we should expect to have some interface which contains all our log data. No dashboard active for the current data set. Check out on scalars. What do we have? Anyway, let's do this. Let's check on this. Let's have logs. Run this again. Okay, and there we go. We see now that we have this interface which pops up. What do we see here? We have this logs. We have both train and validation. You could pick this out. As you could take only the training data, you could see only training data, and then here you have the scalars. The scalars basically stores all this information which we pass in here, like the loss and the metrics. Recall that we had defined this metrics here, so we are gonna get all this metrics information. So unlike previously where we had to manually do this step and do this step for the loss and the accuracy, now this is done automatically. So let's run this and then we will compare what we get here with what we get from Tensorboard. You can see here we have this loss, and then we get back to Tensorboard. We have this level of scalars. Let's reduce this accuracy. Let's view the loss first. So let's reduce this. Okay, we check out, we have this epoch loss. Now this is what we get for the loss. Let's include the validation. So you see you have this plot right here. Clicking on this, you could also expand. So you see this is the plot we get. Now what do you notice? You notice that it's exactly the same as what we had here, but this time around we didn't have to write any code. All this information was automatically locked in this file here, and Tensorboard took care of the rest. So that's how this works. It's really very interesting, and it's a kind of tool you want to master how to use, because when working on different machine learning experiments, you wouldn't want to always have to log all these values by hand or manually. You want to have this done automatically. Now one other interesting point is you have all the metrics here. You just have to select any one. So let's look at the accuracy, which we've seen already. We can check out this. Let's click here. Okay, so we see this accuracy, and then let's scroll down. You see you could compare it with what we have here. See, we have this zip around this should be the 9th epoch, or let's say 8th epoch. Anyway, let's come back and check here. Let's scroll up from here. It's actually an interface in this other interface. So we have this, you see, at this 9th epoch, what do you see here? You see, notice on this here you will have this name, train, smoothed, value, what do we have, step, 9th step, the time, and that's it. Okay, so there we go. We see how we could plot all this automatically, and then you could get at any point. See, you could go through each and every point and then get all the exact values. So that's how we look at this. Let's reduce this. We could take now let's say precision. So you could see, monitor the precision. You could also check out the number of false negatives. You see how this, as you keep on training, the number of false negatives keep reducing. And then the false positives, what do we have here? False positives, that's loading. While that's loading, let's scroll down, and we have the loss. We've seen this loss already. We have, let's look at true negatives. That's loading. True positives. Here's a plot we get for the true positives and the true negative. And in the section where we have this evaluations, practically the validation metric and loss that we're plotting against the number of iterations. So that's what we have here. It's just like the validation accuracy versus the iterations. If you take off the train, you see nothing really changes here. But when you do this, you see all of that goes. So that's validation, and we could monitor this and observe that the highest accuracy we have is 94.09%, or no, it's 94.21%. Scroll down, we have precision. What's the highest precision here? It's 93.6. No, the value is 94.39%. As of now, we've been able to log this information just from compiling our model. So because we passed our loss and the different metrics, we're able to log the information and visualize it on Tensorboard. But there are other possibilities. That is, it's also possible for us to log information manually instead of just logging only this information. So what we could do is log, for example, image data. We could log even this different learning rates here. So we are gonna log, or we can log the learning rate values for each and every epoch. And this gives us that freedom to log in just any kind of scalar or quantity we want. So here we have this metric. We're gonna create a metric directory. This is gonna be logs, and then in here we have metrics. Then what we're gonna do now is create this train writer, because now we are doing this like manually. So we create our train writer. We have tf.summary.create file writer, and then in here we have our metric directory. Okay, so that's good. We have our train writer created based on this metric directory, which is going to be in the logs. So in those logs, we're going to create a metrics directory. So that's it. We have our train writer. We could run the cell. Then just in here we have with. So once we're done with this, with train writer as default, we want to have this locked. So we have tf.summary.scalar, and then we specify that we're dealing with the learning rate. So our learning rate, and then we're going to pass in the learning rate actually. So here we pass in the learning rate, and then we pass in the epoch. So this is like as you could see here, you have data. Look at this pop-up. You see here you have data, and then here you have steps, or rather step. So you have the name of the scalar, you have the data, and you have the step. You also have the description. So here we have the name, which is learning rate. We have the data, which is this learning rate, and then we have the step, which is the epoch. Now we'll have to do this like with this. We have to put it in each and every one of this, since either we get into this or get into that. But to avoid writing this twice, we just have to set a learning rate. So in here we define this learning rate, and then here too we have our learning rate. There we go. We have the learning rate, and then out of this we return our learning rate. Okay, so that's it. Now we return the learning rate, and then we are also logging this data. So here we should change this and have learning rate. So that's it. Now we have the set, and then we could go on and train. Before training, recall each time you want to log in this kind of data or this kind of custom data, first thing you do, you create your writer. That's, you create this file writer. After creating the file writer based on a given directory that you set, you now go ahead and then put this in this train writer scope right here. So with this, we can run this now. We've run this already. We can run this now, and then since this is our scheduler callback, we'll have to add this in our fit. So let's go ahead and add it in this our fit method here. Let's take now just 5 epochs. So here we have Tensorboard callback, and then we have scheduler callback. Okay, so we run this now and see what we get. That's training. Our training is now complete. Let's go ahead and check this here. We have our logs. You see we have this metrics and we have this locked. Next step, we go to visualize. So here we have this Tensorboard, and then here let's run this first so you'll see what we get. As you could see right here, we now have this learning rate which has been logged and which we can visualize. So you see as we go from this epoch to this epoch to this, if we set this at 0 smoothing, we have this. Now the reason why after this we don't get any value is because of what we have here. So we sent the learning rate into this tensor, and what we should be doing here is getting that numpy. So we should have this learning rate right here, learning rate equal the learning rate, because this is going to be converted into a tensor. So we have learning rate at numpy, and that should be cool. Okay, we run this again and that should work. And then to view or to have immediate response, let's set this to just 1. So if the number of epochs greater than 1, then we would have the learning rate being modified. So let's get back again to training. This time around, let's say we just have 3 epochs. Okay, this time around we have this actual value logged, and so we get back. Let's reduce this custom training loop. We get back to our visualizations. We will run this again. Getting back here, we see we start with this loss, and then this drops after this second epoch right here. As you may have noticed, each and every time we run new training process, the previous values or the previous logged input data is being deleted. So what we could do now is we modify this file name. That's this logs file we're using here, where this folder name now depends on the current time. So here we're gonna have date time dot now, and then we get a string from the time, and then format this output. So here we're gonna have percentage the day, percentage the month, the year, and then we specify the exact time. So here we're gonna have the hour, the minute, and the second. Now let's go ahead and import date time up here. We have date time. So yeah, we import date time simply. That should be imported. Okay, so we run that and that should be fine. Okay, we've imported date time. Let's get back, and then let's print out this log die right here. Let's have log die printed out. See what we get. See, we have this logs, and this is actually our new folder. Now if you print out this again, you see we're gonna have a different folder, and this is important because each and every time we do not need to cancel our previous runs. From here, let's take this off and then set this as our current time. So current time is equal to this. Take this off. Here's our current time, and then we have this plus current time. Okay, and then here we do the same. We have this plus current time. Let's take this off and then have the current time here. Current time. If we get back to this training, we could run this again. Training now complete. As we could see here in this logs, we have this new folder created, which is dependent on the time in which we decided to do the training. And then in this metrics, we also have this, but what we want to have is actually just this one folder which contains the train, validation, and the metrics. So we should modify this right up here. So instead of having this metrics before, we should take this off. We should take this off and then add it later on. We have plus, and then we add this. Okay, so we have this slash and then slash. Then we should take this now. So that's it. We have recreated this, and then we will rerun again to avoid this kind of error. So let's go ahead and retrain our model. Let's have it to be here. It's fine. Let's say 2 epochs, and then run that again. Okay, the training is complete. Now you'll see that if you open this up, you have train validation. This is what we had previously, but now we have metrics, train, validation. This is exactly what we want. We want to be able to log all this into this one directory, and you'll now notice how we do not have to erase previous logs. So let's go down to running this again. We run this, take this off. Okay, here we go. We have this information now logged. You see we could take all this previous logs out and focus on just this log here. So let's have this one. This should be 05, the same, ends with 71. So we want to focus on this one which ends with 71. And okay, here we go. So we have this metrics, this train, and this validation. For this, we are not interested in logging this. So that's it. Let's take this off now and then get back. So you see here we have the learning rate, we have the epoch accuracy, we have this true negatives, we have the recall, and that's it. So here we've seen now how to create these directories which are dependent on the current date and time. Now the next step we'll be doing is how to actually do this logs without or when we're doing a custom training. So let's get back to where we did this custom training loop. We had this custom training loop, and then we have this feed method which comes directly with TensorFlow. So what if we now try to use, or what if we actually use the custom training loop and we do not have the possibility of just simply saying, okay, callbacks, Tensorboard callback, and then the job is done. What if we just have this custom training loop? in this case, we are going to use exactly the same process we've just followed here. So we're just going to create this file writer. So let's copy all this, and then just as we did here, actually we're just going to put right in this scalar values, and then like create the scalar, put in the data, and then specify the step. So that's basically how we're going to function. Now let's get back to this our custom training loop. We're going to add this code cell, and then in here we have current time as usual. We have now, let's call this custom directory. We have logs, current time, and then we have custom. Let's call this custom train writer. Let's call this custom train writer. Custom train writer. And you could also define a custom validation writer. We could have that too. So let's have here custom direct, and in here we will specify also train. So notice that since you were using this fit, what we got was the we automatically got this train and validation. So what happens in the background is these two file writers are created, that is the train and the validation, and we're just gonna do exactly that here. We have custom, and then let's say we have custom train directory, custom train, and then custom validation. Okay, so we have that, and then here we have custom validation. Now we specify our writer. We have custom train and custom validation. Then here we have custom train, custom train, custom validation. Okay, so I think this is okay. We could now run this, and then let's copy out this code we had put out here in the section on the scheduler. So let's simply copy this out. You see how easy it becomes when you have already done this. So here you now have to say, instead of just only printing this out, let's have this. So with our let's get the name from here, with our custom train writer, and then here we have with our custom train writer. Custom train writer, we have the loss. So we have the loss, let's call it training loss. We have the training loss. We have the data. The data is now this loss here. It's this loss. So we have the data which is passed, which is now the loss. And then the step is the epoch we have here. So that's it. Okay, we've logged this. Let's now go ahead and log for the accuracy. So we paste this out, and then we have training accuracy, and then the accuracy is what we kind of paste out. We will say metric the result, metric the result. Okay, metric the result, and then we have the step specified. So this is for the training process. We could separate this block, and that's it. Okay, so we've done this. We now simply copy this out and then do the same for the validation. So in here, instead of writing this out like this, we could simply put out your custom val. We have custom val, take this off. Here we have validation loss. Here we have the loss, but this is loss val, that's fine. We have metric val, that's fine. We have validation accuracy, validation accuracy. Now you have this too, take this off, and then we have the val. Okay, so that sounds fine. Everything looks okay. We could now run this here. So let's run this. We run this, and then we run neural learn, and then we start with the training. Training now complete. Let's go ahead and see what we have. You could check out this logs. You see we have our values now logged in here: custom, train, and validation. So we have this logged. We now go ahead and rerun this Tensorboard. As you could see, you have all these values here. You could, as usual, let's take this off, toggle our runs, and then let's pick this very last one. So we pick this last one, and also pick out this one, because this is the train and this is the validation. Then we come right here and check out the training accuracy, training loss. There we go. We have training accuracy, we have training loss. If we do this, you see we have, okay, we have the train accuracy, we have the train loss, we have the validation accuracy, and we have the validation loss. Now if we want to take off all the information stored in the logs, we could have this command. So we remove all this information and then we specify the logs. So we run this and then opening up this, you see you don't have the logs folder anymore. At this point, we'll go ahead and see how to display image data with Tensorboard. So unlike previously where we've been displaying information like the loss, the different metrics, now we'll see how to implement, or rather we're going to display image data like the confusion metrics we had seen previously. Let's get back here. We have this confusion metrics right here. And what we'll do now is after each epoch, we are going to display this confusion metrics with Tensorboard. That said, we're going to copy out all this code we used in displaying this confusion metrics right here. So we have this code. And then we have this log images callback right here with this on epoch end method. And then in this method, we are going to paste out this code we used in visualizing the confusion metrics previously. So here we have this label input. Right up to this, we have the confusion metrics based on this threshold, and then we're going to visualize this confusion metrics. But now, since we're working with a callback, what we'll be doing is at the end of each and every epoch, we are going to display this with Tensorboard. Now that this is set, we are going to, for now, we've actually just been able to visualize this, but how do we put this, how do we make this work with Tensorboard? What we're going to have here is we create a buffer. We have this buffer io.bytes io. Here we have bytes io. And then, so that's our buffer. We are going to save this image, the confusion metrics image, in this buffer. So we have this plt.save fig, and then we save it in that buffer, and then we'll specify that the format should be PNG. So we have the PNG format, and that's okay. So now we have this buffer. We've saved that into our buffer. The next step we'll take is create an image of this buffer. So from here we have this image. Let's take this up. We have this image. We use the TensorFlow image decode PNG method, which takes in this buffer. So we have our buffer get value, number of channels equal 3. That's it. We have this image, and then once we get this image, we then write this in Tensorboard. So we have this image writer which we've created right here, similar to what we've done already. We use this create file writer. Let's modify this and have your image directory. So we have the image directory, and then we create this file writer, or rather we create this image writer. So with this image writer as default, what we're gonna do now is, instead of having this summary dot scalar as we used to have here, now we're gonna use summary dot image. So you could see here that Tensorboard permits us not only input or write scalars but also images, and that's basically all we needed to do here. So let's have this and then run the cell. So we make sure we have this run, we run this, and then we have this log images callback here. We copy that. Now that's copied, we have to reduce this one, and then right here we run this metrics and then compile and run this. We get this error where we said where we have this value error, no step set. So let's get back to this callback, and then we specify the step. So right here we have the step equal the epoch. So we run that again and this should be fine. Training is going on, and then the image data has been logged into Tensorboard at the end of each epoch. training now done, we could go ahead and then run this on Tensorboard. Once training done, we could now visualize this conversion matrices on Tensorboard. So we run this 2 cells, and here's what we get. You'd see here step 0, step 1, and then step 2. This is because we actually run this for 3 epochs. So we could notice how, let's come back to the top. We notice how here we have 53, and then as we keep training, this drops to 35, and then finally here, let's scroll down a little. Finally here we have 240. So this tells us that the last epoch wasn't helpful in improving the number of false negatives. You could see also, even with the validation, that here we had 16 false negatives, 8 false negatives, and then this value rose up to 111 false negatives. So it's kind of similar to what we have with the test data, which is exactly what we're logging in the Tensorboard. And now that you know how to log in image data with Tensorboard from the example on the conversion metrics, what you could do is log in directly this ROC plots. You could also log in data like this one right here, where on the test data, you're going to put out the actual value and what the model predicts. And so that's it for the section on logging in image data. Now let's move on to visualizing model graphs with Tensorboard. To visualize the graph, we're going to rerun this command to delete all the logs we've stored so far, and then rerun this Tensorboard callback once more. So we have that, and then let's get back to metrics. We run this, and that's fine. Now we have the training done. Let's go ahead and rerun this again. So we run this 2 cells again, and as expected, here's what we get. So here we have the scalars, and then if we click on this graphs here, we'll have this graph coming up. Let's reduce this slightly. Okay, so we have this. Notice that the graph type here is up graph, and this actually means we're viewing the graph from the operations level. If you could come right here and zoom in, you see you have the conf layer, you have the conf layer again, dense layer, and then zoom in this other way. Here you see you have the Adams optimizer. Let's double click here. Where you have this plus, you double click, and then you get to see exactly what goes on in this Adam optimizer. Let's reduce that, zoom in, and then let's double click again to reduce this. Okay, so here you have that, and for this dense layer, you could double click. You see you have that. You see you have this kernel. You double click to better understand what goes on. And as you could see here, we have this regularizer. So it's the regularizer we had defined previously. Now let's reduce this by double clicking. Let's scroll here. We double click that, reduced, and then double click this. So basically, thanks to Tensorboard, we're able to visualize exactly what goes on under the hood when TensorFlow creates these graphs, which in turn permit us do computations even faster. Now, another way we could look at this is by coming right here, the stack, and selecting keras. Once we select this keras, we, instead of having the operation graph we had just seen, we now have this conceptual graph. We'll see that this is going to be quite easy compared to, or easy to understand compared to what we had done previously. So yeah, this focuses on the keras model we had built, the keras sequential model we had specified. And here what we have is, you see the input. So unlike previously where we had stuff like the Adam optimizer, the different metrics, and the, say, loss computations with the up graph, here we have just the keras model. So here you have the input, conf, batch normalization, max pooling, drop out, conf, batch normalization, max pooling, flatten, dense, batch norm, drop out, dense, batch norm, and finally dense. So that's our conceptual graph. And that's it for the section on graphs. You see, you get to understand exactly what goes on under the hood thanks to this visualization, or better still, this graphs visualization made available with Tensorboard. Now, as we go ahead with building these models and then training them, you may sometimes wonder why this value 6, for example, was picked, why the kernel size 3 was picked, maybe why the 16 was picked here, why 100 was picked, why not say 32, why not say a value like 100 here, why others values were picked. And then looking at the dropout rate, what makes us pick a given dropout rate, what makes us pick a given regularization rate, and so on and so forth. Now, although in this particular case we're building this model based on the Linnet model, which is some like a model which has already been built and tested, we would see another technique known as the hyperparameter tuning, where we'll be able to select the best values for these different hyperparameters automatically. Now, these hyperparameters must not be only this which we've picked out here. We could also have hyperparameters like the learning rate, like even the choice of this optimizer, and so on and so forth. And this way of deciding this best parameters for our model and model training is known as hyperparameter tuning. Now, we're going to see how to do or carry out hyperparameter tuning with Tensorboard. So yeah, first thing first, we carry out those imports. We have from Tensorboard plugins hparams, hyperparameters. We're going to import API as HP. Then right here, we're going to redefine this model, or we're going to restructure it. So instead of having just the regularization rate, dropout rate given to us like this, what we're going to have here is, here for example, instead of having this dropout rate, we'll have hparams, and then we'll have HP dropout. And the aim of this process is to ensure that if we have this, suppose we have this model here, and then after training we have an output at accuracy, we want to be able to modify the parameters which make up this model and see how they affect the accuracy, such that we are going to pick out the best parameters, or we're going to pick out the parameters which permit us get the best possible accuracy. So that said, instead of having the dropout, we just have this variable dropout. And then for the regularization, we're going to do same. So you're going to have hparams. Instead of regularization rate, we're going to have this, and then we have HP regularization rate. Then apart from this regularization rate and dropout hyperparameters, we're going to include just right here. Let's start with this one. So let's copy out this. We have hparams, and then we have HP number of units. So here we have number of units, and then we'll call this 1, because just after this we're gonna have number of units 2. So here we are gonna be able to pick out the best possible values for this hyperparameter here. So let's have this here 2. Okay, so that's it. The other hyperparameters will be included when doing the model compilation. So let's include this model compilation, and then we're gonna carry out the training in here. So we have this. Let's take out the summary and then take this back. Okay, so that's it. Now we have this model compilation right here, and then we have the optimizer. But what we're gonna do here is we're gonna fix this optimizer. So we're gonna have the item optimizer, and then we'll specify the learning rate to be hparams, and then we have your HP learning rate. Okay, so there we go. This looks fine. We have the loss binary cross entropy, metrics accuracy, and then we do the model training. So once we do this model training, we are gonna get the accuracy. That's, we're gonna train the model, we're gonna evaluate the model, we obtain the accuracy, and then Tensorboard will permit us modify all these different parameters such that we now get the parameters or the specific values which permit us maximize this accuracy. So here we're gonna create a function which is gonna return the accuracy. Let's have this to the right, and that's it. We have this method which we'll call model tune, and then it's gonna take hparams. So it's gonna take this hparams, and then it's gonna like take different value for each params, and then based on the accuracy, we're gonna know after those different training steps which values for this hyperparameters best gives us the best results. So that's it. We have that, and then we return the accuracy right here. Then we're gonna define the range of values this different hyperparameters can take. So like this one, let's copy this out. Let's say we want to get this HP number of units 1, paste this out here. We're gonna have HP dot HP params. There we go. And then we have the name specified. So we have number of units 1, and we also specify now this range. So we have HP dot discrete. So let's have discrete, and then let's say we want to pick out those values between the range say 10 to 100. Now let's take this powers of 2. So we have 16, 32, 64, 128. Okay, so that's it for the first. And then for this next one, we have 2 right here. Let's have that. And yeah, units 2. There we go. We have that. Fine. Let's copy this again, and then we repeat the same for the dropout. So here we have dropout. Take this off, and then here we have dropout. For the dropout, we're gonna take values between 0.1, 0.2, 0.3, and 0.4. Anyway, let's say we want to take between 0.1 and 0.3. And then from the dropout, we have the regularization rate. So make sure you see that we're taking typical values. So here, typical values for this number of units will be this, and for the dropout will be this. For the regularization rates will have different range of typical values. So here we would have 0.00, yeah, let's say 0.001, 0.01, and then let's say 0.1. So that's it. What's next? We have the learning rate. So let's copy this out. HP learning rate. And here we have 1e -4, 1e -3. Okay, so that's it for the learning rate, and that should be all. So we have nothing left actually, so that's fine. So there we go. We've defined all these different ranges. So we're gonna search in this range, search in this range, search in this range, search in this range, search in this range. Now notice that this is actually discrete value, so it's not like we're gonna pick between this value and this value. We're just gonna basically pick this value or this value or this value or this other value. And now to perform this grid search, we are gonna go for number of units 1 in this range that we've specified here. So we're gonna have in HP num units 1, there we go, dot domain dot values. Here we have values, there we go. And then we're gonna do the same for this. So we have for num units 2 in HP num units 2 dot domain dot values, and then for the dropout rate, and then the regularization rate in the regularization domain, learning rate in the learning rate domain. We are now going to create this hparams dictionary. So we have hparams right here, which is going to be our dictionary, and it's going to contain the different values here. So we'll start with this HP num units 1, and then what we're gonna put in here is this value we have here. So the value we pick from this domain is what we're gonna pass in here. So we have num units 1, 1. There we go. We now repeat the same process. So we just have here 2 and then the rest. And there we go. We have the remaining parameters. And then from here, we are gonna create a file writer. So for each run, because here we're gonna have different runs for the different values. So for each run, we're gonna define the file writer. So here we have the file writer, tf summary, create file writer, just as we've seen already. So here we have the file writer, and then we specify this directory. Now we want this directory to have different names based on the exact run number. So let's say we want to have run number here, which we initialize to 0, and then we have this. So let's have this logs slash let's just put in the run number in here, string we have the run number. Okay, so that's it. We have that, and then after each and every run, we want to increment this run number. So yeah, we're going to increment the run number equal run plus equal 1 plus equal 1. Okay, so that's it. Now we've defined this file writer. That looks fine. Next thing we want to do is with this file writer as default. So we have this default as default. We'll now log in the current hyperparameters. So we have hp.hparams, and then we pass in this current hyperparameters. Recall, we are going to sweep through all these different values, and then for a particular run, we want to know exactly what we're passing in, and that's what we're going to pass in here. So we have hparams, that's fine. And then now once we've passed once we've notified Tensorboard that this is the parameters or the hyperparameters we're working with, the next thing we want to do is to pass this hyperparameters in this model tune method right here. So here we're going to pass in now this hparams, which we just defined here, which is a function of this different values we are going to be sweeping through. So here we're going to have model tune, which is going to take in the hparams, and then it's going to output, like from here it's going to output this accuracy. So here we're going to have the accuracy. So we have the accuracy, which is that. And then once we get this accuracy, we are going to log in its value. So we have tf summary scalar. So we log in the scalar accuracy, and then we have the accuracy value logged in. So that looks fine. We have this run number. Why do we have a red here? That's actually okay now. So let's get back to this. Now we could run this cell. We run the cell. Everything looks fine. And then we now go straight into this hyperparameter tuning, where we're going to pick out the best values for our hyperparameters, which actually give us the best accuracy. So for each step now, we want to, let's say, print out this. So we'll print out the hparams. So our hparams is, so we have hparams, there we go. And then we also want to print out the current run number. So what we're going to have here is the hparams for the run. Let's specify the run number. Our hparams is that. So our hparams is this, and then we format. So we have that, and then we have the run number. There we go. So let's have this here, and then I'll run this cell. So here's what we get. We also modified this code here to contain each and every value in this hparams. So we get this kind of output, and we make this run for like let's count this, for like 287 times. So we have 287 different runs, and then from here we run the cell and then run this too. So from here we have the scalars. Here are the different accuracies we get. Anyway, we're not very much interested in this for now, because we're interested in looking at this hparams here. Now let's start with this table view. You could see here that with this table view, we could see the different values, the different hyperparameters we made use of, or we tuned throughout this process. So you could see, let's scroll up a little. Here you see we have the regularization rate, number of units, dropout rates, and then let's scroll down again and then go this way. You have okay, so we have number of units, 2, learning rate, and then the accuracy. So you see here that the accuracy changes based on the different values we have for this different hyperparameters here. Now another better way of looking at this is this parallel coordinates view. As you can see in this parallel coordinates view, you get to like pick out this highest accuracy value, and then if you follow this path, you get to see that taking a learning rate of 0.0001, and then here let's just look at this part. So you see, notice this red part here, which you can actually turn to green by clicking on it. So you see it turns to green. You have 0.0001, and then the number of units 2, it's like around 32. Here we have dropout rate 0.2, number of units 1, 32, regularization rate 0.01. So these are the best hyperparameter values we have, and we can now make use of this information to better create our model. So now instead of having a model like this, so now we will modify this, and then instead of having let's get back to what we had up here. So what we're saying is, instead of having this here where we had 10, now we could take this to 32, and then right here it's 32. Then we could pick the regularization rate to 0.01. So we'll have the 0.01 dropout rate. We didn't note that dropout rate. Let's get back to that. The dropout rate 0.1. No, 0.2 actually. So dropout rate 0.2. That looks fine. Learning rate 0.0001. So that's it. So we now see how to better pick these values thanks to this hyperparameter tuning, which we could do easily with Tensorboard. So let's get back to this, and then we have 0.2 right here. Now it should be noted that the method we've used so far is grid search. That is, we've specified those different ranges, and then we've some sort of search through those different ranges, and then we've gotten the best possible parameters which maximize the accuracy value. Now another very popular technique is the random search. With a random search, we'll just define a range and then pick our random values in that range. So unlike the grid search where we have some defined or predefined values which we have to search through, with a random search we kind of like pick values at random. But then they both have their advantages and disadvantages. And one thing you could take out from this is that with the grid search, since you have a fixed range, so you have a fixed range of values which you can pick from, it means if this fixed range of values is very large, it becomes problematic, as this process of searching is going to take a very long time. So you may take a very long time before finding your best hyperparameter values. Let's reconnect. Whereas for the random search, since we are not going in a particular order, it happens that we may even get the best hyperparameter values after just one step. So after just going through, or after just one run or a few runs, we may already get the best hyperparameter values, just like we may get these values after 200 different runs. So if you have enough computation power, you could make use of the grid search, since you're more sure of the different values you're going to be picking from. And if not, the random search will be a better option. Another very important aspect of Tensorboard is Tensorboard's profiler. With Tensorboard's profiler, we're able to evaluate the TensorFlow code, and based on this evaluation, modify this code to ensure that it runs as efficiently as possible. That said, to make use of the profiler, we're going to start by installing this Tensorboard profiler plugin. So we have your pip install this, we run this cell. The profile plugin now installed, we now go ahead and run the cells. Right here we're gonna have this profile batch. So notice that we have this profile batch right here, and this value specified here has to do with the range of batches to be profiled. And so here we could take, say, 100 to, let's say, 132. Okay, so that's it. So we have that set. We now run this cell 2, looks fine. And then we could start with the training. We have this Tensorboard callback which has been added here. So we run this to start with the training. Training now complete. We go ahead and run this to cells. Just as expected, we have the scalars, we have the graphs, we have this distributions, we have this histograms, time series, and then in here we have this profile. And here in this overview page, see you have different pages. In this overview page, we have this performance summary. We're given the average step time, all of the time, compilation time, output time, input time. Notice how this input time is relatively larger than the others. And you'll see that, or you'll notice that here, the input time occupies the largest part of the step time. So that's why you have as recommendation to first focus on reducing this input time. And then we have 7.5% of total step time sampled is spent on kernel launch. It could be due to CPU contention with TF data. In this case, you may try to set the environment variable TF GPU thread mode to GPU private. Then we have 6.6% of the total step time sample is spent on all other times. This could be due to Python execution overhead. Only 0% of device computation is 16-bit, so you might want to replace more 32-bit operations by 16-bit operations to improve performance. So this actually means we could make use of mixed precision training. Now we're going to look at mixed precision training in subsequent sections. We also have this other tools we could use for reducing the input time. This input pipeline analyzer. You could click here. You have this input pipeline analyzer. Now notice that you have these different tools here. So we have the overview page. Let's go back to overview page. And then here we have this input pipeline analyzer. Let's scroll down here. We have the input pipeline analyzer. We have this TF data bottleneck analysis. You could click on this. You see we have this TF bottleneck analysis. And then let's get back to the overview again. Let's scroll up, and then you have this trace viewer right here. So you would also find this trace viewer in here. You could scroll here and you have the trace viewer. Now getting the summary of the input pipeline analysis, we get to see exactly the breakdown of the input processing time on the host, because we've seen already from here that the input processing time is kind of taking up close to 68.4% of the total step time. So here you could see we have the data processing, which is like the main reason why this input processing time is that large. And we have this different steps we could take. So what can be done to reduce above components of the host input time? Encoding data. That is, you may want to combine small input data chunks into fewer but larger chunks. Data processing, you may increase number of parallel calls in the data set map or pre-process the data offline. Reading data from files in advance, reading data from files on demand, or the data reading or processing. And then here we have a more detailed input operation statistics. So let's click on this, scroll up, and then you could have this statistics given to you right here. So as you could see, we know exactly why our input processing is taking up much time, and based on this different suggestions we could reduce this time. Now from here we have the kernel stats, then we also have this memory profile, and then we have the pod viewer. From this pod viewer we have the TensorFlow stats, and then here we have this TensorFlow data bottleneck analysis. You could also look at this from here. You see we have the root prefetch. Look at the self duration here. 10 microseconds, 36 microseconds. See, this one now is very large. So here's our bottleneck at the level of the mapping and batching. Shuffling just 118, 373, prefetching, and so on and so forth. So we now know that the problem comes from the mapping, as we have seen it, as we've seen previously. And now selecting this trace viewer, we have this here, and we'll make use of this here. So you could carry this around by clicking on this, and then you have the arrow, you have this to like pull this from place to place. You have the zoom, so you have the pan, you have the zoom, you have this timing. So let's click on the zoom, and then you click and you drag to the top. You could zoom in and zoom out. Now you notice this train, we have values from 100. Like, let's get back to what we had defined previously. Here we have 100 to 132, and that's why you'll notice here we have this train from 100 to 132 too. Getting back here, you can zoom. See, you have that, and then you could click here on the pen, and then you pull this to one side. Now stopping right here, you could zoom again, and then you get to see all those different operations carried out during a single process. All those different operations carried out during a single training step. And with this timing tool, you click on this timing tool, you can be able to, like, let's zoom this again and zoom, and then drag this here, zoom again. As we're saying, measure the timing for a given operation. So once you click here, you just click, and then you see you drag, and you can measure the timing for different operations. You see you have the time here, 166.5 microseconds. And that's it. We now go on the distributions. Here we have batch normalization. Let's check out on this conv2d. You see that different biases and weights. That's, you see the kernel here, the weights have values which fall under this zones. Like the values fall under, the values are between -0.3, -0.3, 0.3 for the biases, between -1.2, about 0.4, and then for conv this dense, we have this other dense layer here. We have this conv2d2, which you could see here. See the range of values, and then we have the dense 1, we have the dense 2. We also have the different value ranges for both the kernels and the biases. So that's it for this distributions. We have the histograms too. You could check this out. Time series. Anyway, this time series is kind of similar to information we've seen already. So here we have this all. We could select just the scalars. So here we have the epoch loss. We have the different evaluation accuracy, and so on and so forth. Now click on images. You select only images, nothing to be shown. See, that's why you have no information here. Click on histogram, and then you have the histogram data we've just seen already. That's it for the section on Tensorboard. Tensorboard has other functionalities which we shall explore subsequently, and thank you for getting right up to this point.